All right, guys. So the article that I read was called "A Path Towards Autonomous Machine Learning" by Jan LeCun. And in the paper, Jan LeCun basically proposes his idea of how he thinks we should reach machine intelligence. So the first important point in the paper is that ML models severely lack the ability to adapt to a new situation they haven't seen before. For example, he discusses how adolescents can learn how to drive a car in hours, while ML models require very large iteration of training so that they can know how to respond in the rarest of situations. So what do human babies have that machines don't? LeCun hypothesizes that the difference in humans and animals is that they have the innate ability to learn world models or internal models of how the world works. So LeCun proposes a model right here consisting of 6 separate modules. So I'm just going to briefly go over each of these modules quickly. So the first one is the configurator module, which is at the top here. This can also be thought of as the composer of essentially the orchestra. So given a task, the module pre-engineers all the other modules. The second module is the perception module here at the back. And this module estimates the state and can represent the state um, of the world in a stratified manner. And the third module is the world module here in the front. And it's this is essentially the head honcho or the main piece of his overall model that I will explain more in detail in a little bit. And then the fourth is the cost module, which encapsulates the critic and intrinsic cost. And the cost module is essentially the same as the definition that you probably already know of cost. The goal is to minimize the cost function, which in turn explains how well the model is performing on a given data set. And last but not least is the short-term memory module, which is used to create order to the predictions. This module stores information about each state of the world as well as corresponding cost functions. This module is also needed to build long-term memory. So the key point of this paper describes a roadmap for developing machines whose behavior is intrinsic rather than hardwired or requiring supervision/rewards. So how can we create a world model? Jan proposes using self-supervised learning, otherwise known as SSL, and LeCun is basically known for his strong belief in SSL. So essentially, in short, here is the self-supervised learning, and SSL is necessary to allow machines to gain human-like reasoning and understanding. So how can we create multiple plausible predictions and teach the models what is important to predict and what is not? So this brings us to the most important part of the paper, which is the joint embedding predictive architecture, otherwise known as JEPA. So JEPA is an SSL energy-based model, otherwise known as an EBM, that captures the dependencies between two given inputs, for example, X and Y. So an example of applying JEPA to a recommendation task would be having historical data about songs that a user has listened to and wanting to build a recommendation system that can predict whether the user, what songs the user would want to listen to in the future. So in this case, X right here would be the last 5 songs that a user has listened to, and then Y could be Y would represent the future music that the listener would listen to. So JEPA has the ability to predict in representation space. So the two inputs are fed into the two encoders right here and right here to predict S sub X and S sub Y, with both being two abstract representations of each input. So the predictor can use latent variable Z right here to minimize information content, and the prediction will vary given a set of feasible predictions for the next song. So the ability of JEPA to predict in representation space makes it basically a lot more desirable or preferable to generative models that directly produce a prediction of Y. So an advantage, as mentioned in the paper by LeCun, is that JEPA can choose to ignore certain details that are not easily predictable or relevant. So LeCun explains that in a video, prediction is it is possible in a video to predict every pixel, value, or detail of a future frame. He then writes that the details of the texture on a carpet, the leaves of a tree moving in the wind, or the ripples in a pond cannot be predicted accurately, at least not over long time periods and not without consuming enormous resources. So lastly, for the overview, this basically means that they can be stacked on top of one another to learn representations for not only short-term, but also long-term predictions. Then the encoding of one JEPA leads to the input of the next JEPA, and so on. And that's basically the end of the kind of the introduction and overview. I'll go over some of the more detailed